Welcome to a special episode of the Ask a Cycling Coach podcast presented by TrainerRoad. I'm Coach Jonathan Lee, and this is, like I said, a special episode. We have two folks here from the company Rockshox. We actually asked a handful of episodes ago because Rockshox reached out to me and asked if we'd be interested in covering a new thing that they were launching on the podcast. We asked our audience if they'd be interested in that because we typically don't get into the more the tech side of things with talking to the companies behind it. And the absolute enthusiasm, it was unanimous. Everyone said, yes, please have them on because we're going to talk about Rockshox Flight Attendant today. It's a new technology that I will leave these folks to explain to us, but it's helping suspension be more efficient, helping us save time on the cross-country mountain bike side of things in particular is what we'll be talking about today. But I want to have a discussion with these folks also about beyond that, looking at other applications and kind of learning how this new field of engineering, at least how it's being implemented into cycling, could be saving us time across the board. We're all interested in that and getting faster. So this is going to be an interesting discussion. We have Chris Mandel. Chris is the Rockshox and SRAM PR coordinator. Chris, good to have you.
Thanks so much for having me. I'm excited for this conversation and speak to your listeners.
Yeah, man. Chris is a rider too, if you're listening to this. And Chris is gearing up right now for a pretty gnarly, sweet race there in Bellingham, Washington. And he's no stranger to doing big days. So he'll be relevant and I guess relatable to a lot of us. And then Joe Schoolcraft. Joe, good to have you. Electrical and software engineer. Also a cool title that we want to apply because it sounds really neat is mechatronics engineer. Joe, thanks for joining us on this podcast too. We appreciate
thanks so
it.
much for having me on.
Yeah. Can you, and I'll let you guys decide who wants to take this one. And for those wondering too, we're recording this, we have a low bandwidth scenario, so we can't see each other. So pardon if we speak over each other a little bit, give us a little bit of grace. But can you guys first, before we get into flight attendant, or actually somebody explain flight attendant for me. I don't know if Joe or Chris, you want to do that. And then I want you to very basically also describe suspension from two perspectives, like what is compression and what is damping. So then we can understand what's going on here with the changes that it makes. But who wants to describe flight attendant for us?
I might take it because I can take it from the top and then we can move in.
Cool.
So
awesome.
I'll actually start with suspension and then we can go to flight attendant and then I'll probably hand it off to Joe to really drill in on some more specific details with flight attendant. But suspension on a bicycle, what we're trying to do, especially in the cross-country space, is we're trying to provide the rider with control and traction. And we want to have that rider be able to control their bike and have good traction with the ground while also being very, very efficient so that the power transfer from the rider to the bicycle there's no wastage there. And then we also want to make these components really lightweight. And that's at a very high level what we're trying to achieve for the rider with suspension. And we do that by building a spring and a damping system. And this is true of the fork and the shock together. There's an air spring system, and that is controlling the energy that's going into the system and holding the rider up. It's holding the rider in the correct sag position, and then it's also preventing the rider from having harsh bottom outs. And then we also have the damper side, which is primarily oil driven. We have oil that moves through a set of valves. And this is again true of the fork and the shock. The oil moves through a set of valves on compression, which is when it's going into the travel, and then on rebound, which is when it's returning to full travel. And it is the spring that pushes the fork or the shock back to top out. And those valves, we can vary those valves in a lot of different ways to provide more or less damping. And that is what allows us to build a lot of efficiency into the system. So before we even get into flight attendant, with any suspension product we make, we do a ton of work on the valving side to make sure that the valving is fitted to the bike, the particular bike that it's going to. So if you had a Specialized Epic as an example, we work with Specialized to build special valving specifically for the rear shock that comes on their bike. We tune that for the leverage rate curve of the bike, and we also tune it for the specific needs that Specialized has. And we would do that for any of our OEM partners that we have, Trek, Cube, Scott, any of those customers. We would work with them to make sure that the valving is matched to their frame. And then on the fork side of things, we're doing something very similar, but just inside of our own component for the fork, where we are setting that valving so that the rider has good traction, good control over their bike, and maximizing comfort through all those steps. The level that Flight Attendant brings to it is it allows us to automate the movement of the bike from an open setting to a pedal setting, which is just providing more efficiency, to a full lock situation, which is providing the maximum amount of efficiency for the bike. And what's awesome about being able to automate that and make it so that the rider doesn't have to do anything in terms of input is it frees the rider's mind to focus on what's happening on the trail, so that you can focus as a rider on making the next pass, drinking water, whatever it is, knowing with a high degree of confidence that your suspension is going to be in the optimum state. Optimum for descending, optimum for pedaling across rough terrain, or optimum for sprinting up a fire road. I think at that point I'd turn it over to Joe to maybe talk a little bit more about Flight Attendant, but at a high level, unless you have another question on that, Jonathan, that's what suspension is trying to do.
Yeah, that's a great explanation of it. And going off of that, Joe, maybe I can turn this to you. It's cool because your background is in like acoustics and that sort of thing. And if you think about it from this regard, it's actually like what he's doing now is very similar to this. And I kind of have a question. Perhaps it's a dumb question, and I'm hoping that it can lead to like an insightful answer for us. But as you mentioned, varying levels of efficiency, Chris, like wide open, where that would be if you're pedaling along, that would be where you may be losing more energy to that, up and down movement of the suspension. And then on the opposite end of the spectrum, a fully locked out bike is one where you're losing less energy to that up and down motion. However, maybe Joe, you can explain to me why not just be locked out all the time? Can you kind of take it from that perspective and explain what Flight Attendant does to help somebody get faster?
For sure. So, kind of going back to what Chris was talking about earlier, like suspension's all about giving you grip and control. And so a lot of times whenever your suspension is fully locked out and you're going over bumpy terrain, that makes it really easy for the wheel to lose contact with the ground. And so when the wheel is in the air, you don't really have control over which direction the bike is going. And so because of that, it's really advantageous to make the suspension more soft in those situations and absorb that bump to keep the tire in contact with the ground. And so, yes, while you're pedaling hard and trying to gain as much speed as you can, you want the suspension to be firm, so you're not wasting energy by compressing that suspension. As soon as you get into a bumpy situation, though, it is much better for the rider and for the bike for the suspension to be soft and absorbing those bumps and sticking to the ground really well. So that way you can corner, that way you can brake, you can control the bike the way you want to. And honestly, it's less tiring for the rider whenever the bike is doing the work of absorbing those bumps for you. For anybody who's ridden, a rigid mountain bike before, you know what we're talking about here. You know how big of a difference having that suspension active makes. And so what we're trying to do with Flight Attendant is really give you the best of both worlds, where you can have this really firm pedaling platform when you're wanting to put the power down, but still have all the grip and comfort and control when you're not needing to put the power down and when you're just plowing through rocks or roots or whatever it may be.
Now, speaking from like a cross-country racer in particular, maybe gravel or even the road racers here, they can relate to this. In terms of efficiency, for a long time, we always felt like, when bikes were first, if we're looking at full suspension bikes, and when they were really starting to get to the point where instead of just for downhill bikes, but it was branching out into everyday mountain bikes, we had a long period of time where if a bike, you were pedaling along and you had a full suspension mountain bike, you were just bouncing along and it felt inefficient. And I kind of want to approach this maybe with another dumb question. Is that inefficient? I kind of want to challenge the assumption here of like the assumption that if my bike is locked out, I'm retaining as much power as I can through that drivetrain to making me go forward. And if a bike is unlocked, I'm losing all of that. And I'm in other words, all the work that I'm putting into those pedals might not be going toward forward motion. I guess, is that a false assumption? Or maybe, I'm sure there's a bit of shades of gray to this. Maybe you can explain that a bit.
I would say it's not a false assumption at all, because anytime you're compressing that fork and that shock, that's actual energy going into it. And the whole point of a shock is it has a damper in it. Same with the fork, it has a damper in it. And the damper's whole job is to actually, whenever you compress it, it's supposed to bleed off energy as heat. And so that's what the damper's doing. So it's actually taking your up and down movement of your body and the energy that you're putting into the bike in that way. And it's actually turning it into heat, which is not useful for driving your bike forward at all. And the same thing, whenever it rebounds back, it's the same thing. It's turning that energy of the spring uncompressing and turning that into heat in the rebound stroke. And so you can basically just think about each time your bike's bobbing up and down and you're bouncing up and down, like, oh, cool, I'm heating my suspension up. I'm so glad I'm spending my own calories to do that. And so whenever the bike is locked out, you're not compressing those dampers anymore. And so you're not generating excess heat, and all of the energy that you're outputting is going into moving the bike forward.
Now, on the other side of things, if I'm hitting a bunch of bumps and my bike is super rigid, though, then I'm not well suspended, and that might also cause me to be inefficient. Is that correct?
It's inefficient in a different way. I would say I can't say like 100% like, oh, you're burning more calories by being locked out through rocks and roots. It's more of the fatigue that your body feels. Because for you to be able to absorb, like basically when your suspension's locked out and you're going through bumps and roots and rocks, your body has to be the suspension in that case. And so you're going to feel it through your hands, you're going to feel it through your wrists. And like for a little bit, that might be okay. But over the course of like an hour and a half long XCO race, you're going to be more fatigued at the end of that because of that. And so you're like, all of the physiological stress that you're taking on by having to absorb the bumps on your own, is going to wear on you. Not to mention, you're not going to be able to ride as fast because you have less control and less grip, and you can't handle the bike the way you normally would if the suspension, was doing what it's supposed to do in that case.
It would seem like preservation of momentum, perhaps. Is that a goal from a suspension perspective for you guys? Like to, if you're hitting objects that would kind of stop your momentum, larger objects, whether it's rocks, roots, ledges, anything like that, suspension can help absorb some of that initial like blow and maybe allow better preservation of momentum? Or is that really not a design goal of a suspension engineer?
That's actually a huge element, but I would say that it fits into giving the rider traction and giving the rider control. So if you are coming into a corner and you feel like you have a ton of control into that corner, on your way in, you won't have to slow down as much and you'll be able to carry more speed through the exit. Same would be true like going into a rock garden. And so for us, when we think about that preservation of momentum, it's really like putting as many cards as possible into the rider's hands so that if the rider has traction, if the rider has control, they're able to maintain momentum or check their speed in whichever way they need to make the most of the situation that they're in. And what's, going back to Flight Attendant and thinking about what Flight Attendant does, if you're riding a bike with a remote lockout in a situation where you're transitioning from a climb to a descent, the rider has to go to the lockout setup, whatever it is, remote or mounted on the fork and the shock, and they have to like physically make a decision, or they have to mentally make a decision, and then they have to physically change that. With Flight Attendant, you're just maintaining your riding position, you're just going, and the bike does everything for you.
Yeah. So I have, and for full transparency, you guys sent me a set of Flight Attendant suspension for my Epic 8, and I have been riding it over the past week. I have ridden bikes with live valve, with specialized brain. If you added it up, it's many years that I've spent on different like systems that are trying to do what Flight Attendant is doing. In other words, make it so you don't have to worry about when I need to lock something out or when I need to keep it unlocked. And I'm thoroughly impressed with what you're talking about in terms of control and all of that stuff. I have a burning question though that I want to ask with this, and it's probably way more complex, and I don't even know if you have a good answer for this because I don't know if it's really possible to get a good answer. But let's just lead off with how much time saved or efficiency is gained with Flight Attendant, because we've seen Nino talk about this and using expletives to describe how much he loves it. And I know that at that level, those guys are really, really paying attention to all the details in terms of how they're making their bike faster, everything else. So do you guys have a good answer for how much time saved? Whereas, with aerodynamics, you might say that it saves you 10 watts or something like that. I don't know if you guys can break it down like that.
Yeah, so we can, and I think we can talk about this in two phases. One that's sort of at the high level, and then I'll turn it to Joe to speak to the methodology we actually used. With Flight Attendant, for us, it was really important to provide riders with the benefit of additional speed. That's the point. We want people to be able to go faster on this product. We also think that there is an advantage simply to the increased mental capacity that you have when you're riding your bike with Flight Attendant. I think a lot of people out there have ridden front derailleurs. On mountain bikes, we've moved away from front derailleurs, and part of the reason why, there were so many reasons to move away from front derailleurs on mountain bikes, but one of the big advantages of moving away from the front derailleur is you don't have to think about when you make that big decision of like, do I go to the big ring? Do I go to the little ring? And sometimes you have to make that in a very constrained period of time and result in bad shifts and just chaos. But removing the front derailleur really helped riders to know that they're going to be in the right gear and get into the right gear in any situation and decreasing the mental load there. And Flight Attendant does that. It decreases the mental load so you're able to more readily focus on what's happening in front of you. So from our internal testing, what we have found is that Flight Attendant makes riders 1.8% faster. We also have a World Cup team that has done their own internal testing with their own methodology for that testing, and they found that it made them 2% faster. Speaking from my own personal experience of just getting out and going for a ride, when I'm like thinking about doing a race or training for a race or riding with my buddies and going faster, it's pretty liberating to know that my bike is going to be in open or pedal or lock when it's optimum. And I can then focus on all the other things I need to focus on. Like, do I need to eat right now? Am I choosing the right ride? Oh yeah, this trail dips into this ravine and then like pranks a very steep climb out of the ravine. Even though I'm going downhill right now, I'm going to give myself one extra gear so that I'm like more prepared for this steep climb coming out of there. So it was something that was important to us, and we have done some internal testing to get to that 1.8% increase in speed. And Joe can speak to the methodology that we use there to the level that we can.
Yeah, because that's the really interesting question is how to test that.
Yeah, it's a difficult problem to solve. The main reason it's difficult is because you're dealing with human beings who are variable from one day to the next, and 1 hour and 1 minute to the next. So trying to get like a actual solid number for how much faster a system like this can make you is very tough. And I'm sure many of us are familiar with the tests that we've seen online of people like, oh, do lockouts actually make you faster? And they take a bike and they pedal up a gravel road and open, and then they do it again and lock, and they try and keep the wattage the same. So like, oh, my average is 300 watts for this run, 300 watts for that run. And there wasn't a big time difference. And so like, well, do lockouts really make that big of a difference? And generally they say like yes and no. The problem with that is your power meter at the crank is only measuring what is going into the cranks. It's only measuring the energy that you're putting into the cranks. And so, if you do 300 watts in open and 300 watts in lock, the time is going to be about the same to get to the top of the hill, just because the same amount of energy is going into the cranks, which is going into propelling the bike forward. What it's not measuring though is how much energy you actually spent. So it's not measuring like how many calories did you burn to get that 300 watts. And what I'm saying is like when your suspension's locked out, you're actually burning fewer calories to get that 300 watts than you would be in open, because you're not having to, like I said earlier, heat those dampers up and heat your suspension up by bobbing. And so that's why that kind of methodology of just using, like, comparing a run, like, oh, I did a trail and I was averaging 250 watts in open, and then I did a trail with Flight Attendant turned on, and I was averaging 250 watts. Let's see which one was faster. Like, you can't really compare it that way. So with all that in mind, what we did was we got a good group of riders, and we spent probably a solid 2 weeks, I want to say, of just going to the same course, and using different groups of riders. Like, some people started with Flight Attendant on, some people started with Flight Attendant turned off. And we were always comparing it Flight Attendant in auto mode versus running a 2-position manual lockout. So they would have open or lock. And so that way it's a pretty fair comparison. And actually, it's not entirely fair to, like, our twist lock, because we were actually using Flight Attendant shot cycling between open and lock. And so that actually is easier to actuate than our twist lock. So basically, it was a pretty apples to apples comparison as far as, like, Flight Attendant on versus Flight Attendant off, and the user manually doing it, doing the suspension states. And we picked a course that was actually probably not super good for Flight Attendant as far as, like, how much it could actually help. Like, it was a very difficult course, lots of rocks. It was a very deserty terrain, very dynamic, lots of ups and downs. And so Flight Attendant definitely could shine there, but it also was like, you can't be at the course, you just couldn't be locked out that often. So I would say the course we picked actually made that 1.8% number we got pretty conservative, lower than what you would actually see on other courses that were maybe smoother or a little less dynamic. So that with all that, we then used, like, effort that the rider was outputting. So we used, like, a heart rate and ambient temperature and wattage based effort score to compare efforts, like run to run, like with Flight Attendant on, with Flight Attendant off. And we threw out all the outliers, because some people, we're using amateur mountain bikers here. Like, they're not great at controlling their effort. Some people got really excited on the first lap and blew themselves up. And then, the next laps after that were not good. And that's why we did, that's why we went down there multiple days too, because we knew everybody was going to be in a different spot each day. And so we really tried to cover all of our bases. And with all that in mind, we threw out data that would have helped Flight Attendant look better. We threw out data that would have made it look worse. We just really focused on getting rid of all the outliers and being as honest as we could, because we wanted to know, like, is this actually helping? And that's how we got that 1.8% number. And I would say, honestly, it's probably a fairly conservative number based on what we were seeing. But we would rather, undersell and over deliver than be the other way around. So we actually saw some riders with as great as gains as 5% on average faster. But it's all just day to day, rider to rider, trail to trail. So
is there a certain, and I want to get back to something here on this in a bit, but what you just said, actually, I have a question on that. Is there a certain type of terrain or rider where you feel like a system like Flight Attendant is more advantageous than another?
I would say it's advantageous everywhere, obviously. But where you really, like, feel the difference is, like, on really dynamic terrain, where it's just things are happening too fast for you to try to focus on what your suspension state should be in. And I would say this has been echoed by all of our World Cup athletes. They're like, the Flight Attendant is putting me into a firmer position setting where I never would have bothered to touch that lockout lever before, just because it would have been too much to try and focus on that and still clean the line. And so that's where, like, Flight Attendant is really, really beneficial. It's where things are coming at you really fast, and you're having to just focus on riding. It's giving you efficiency that you never could get by manually locking yourself out, because you just never would touch it. You would just stay in open.
Right. And that's the two big observations that I have from this is that it is locked out and in pedal more than I would have used otherwise, and more than I've used in the past. And then on top of that, the other thing that I've noticed is how quickly and how many decisions it's making that I just would not have made before. Like, basically, I operate at a lower resolution, if that makes
100%.
sense.
Totally.
Like, when I'm riding, I make way less changes. I want to share, like, a quick use case scenario. And for people that aren't familiar with this, that are listening to this and trying to understand, I feel like we had a really good explanation of suspension in the beginning. So hopefully that helps there. And we talked about the fact that you can control that damping or the valving of your suspension. And most bikes these days, cross-country bikes, have a suspension system that it gives you 3 modes, and you usually control that with a lockout. And those modes are open, like Chris talked about. That's the suspension's softest. And then you can go to pedal, where the suspension is going to be a bit stiffer. And if it has like really good design, like Chris was talking about, the brand would have worked with Rockshox to kind of like design the shock so that it would sit at an ideal position when you're in that pedal mode as well. And then there's locked, which is just locked out. And traditionally, and just recently, I've had a bike with just 2 positions. So it was open or locked. And Flight Attendant has all 3 positions available to me. And in a situation where I was riding a trail, and we'll get to this in just like next year, because I want to talk about like, I want to talk a little bit about what's going into like what's driving it to make decisions. But I was on smooth, kind of like packed DG single track, and I was coming into a turn. It was fully locked. I banked into the turn, and I'm quite certain that the suspension moved into pedal mode or open, just based on what I was feeling going through that turn. In other words, good traction, right? And then when I came out of that turn, it suddenly had like a bunch of big granite boulders that you'd ride up and over, and then you'd drop down off of that a couple of feet into like a turn where you'd have to pedal really hard out of it. That's a really complex situation, and I would have just kept it open if I was on my bike. And I wouldn't have picked a middle setting, because I would have just been like, there's a lot going on. I'm just going to pick open. And like I said, coming into the turn, I was locked. It changed to where it was unlocked to some degree, whether it was in pedal or it was open. When I went to go lift up on top of those granite boulders, if it was wide open, it would have been a little bit like waterbed like to me, and I would have like had to work really hard to get up on top of those rocks. And it was firm enough under my feet that it was easy to lift up on top of that. I got on top of the rocks. It was super plush. I dropped off and I landed, and it was supportive. And then instantly I was pedaling out of the saddle, and it was firm once again. So it could have very well, and keep in mind that it's adjusting the front and the rear independently. It might have made, 8 to 10 or 12 changes in a matter of seconds when I would have made none. It was a profound difference. And that actually like leads me, before we get into like what's getting into that, have you guys suffered any like criticism here yet? We had one question get brought up from a listener of like, isn't this considered mechanical doping? Because, I share this example of like the changes that it was doing, and it was, it's pretty profound. We're looking at 1.8% difference. There's certain, probably, I'm sure you could look at performance enhancing substances that are on a banned list that might give you less than 1.8%. So have you guys suffered any of this criticism or thought of that at all? I think it's off base for what it's worth.
We haven't, but I will, like, in that vein, I think, another layer to your example is like, one thing that Flight Attendant can do that no mechanical system can do is that we can have split state. So the shock can be in a lockout mode and the fork can be in pedal, or the shock can be in pedal and the fork can be in lock. So in terms of like mechanical doping, I think everyone is trying to find ways to optimize the performance of their bike, like tires, wheels. As an example, I think, Jonathan, you'd be horrified when you found out that I'm actually running EXO casing tires for my big race on Thursday. But that's because I'm a big dude and I like to keep the air inside my tires, or I need to put a heavier casing on to keep the air inside my tires. So I think we're all kind of like optimizing in different ways. So, this is a system that helps you optimize it. It gets things, and allows you to have more performance in any given situation. But that scenario you just described of like, oh, I would have ridden through that in an open, and not had that additional efficiency, that is really where Flight Attendant shines, because it allowed you to stay focused on maintaining speed through the corner, getting up and over the rocks, being in the right potty position to go off the drop, and then get back onto the pedals through the next turn, and not having to think about your suspension setting at all, but having your suspension be optimized in all those different scenarios is huge. Here's the thing in that rock garden, right? Like, you were pedaling Epic 8 has a relatively low bottom bracket, which is great for cornering and a bunch of other stuff. But Flight Attendant may have given you more pedal clearance by moving you into pedal mode because your cranks wouldn't have gone down as low. So you were able to pedal through a rougher line than you would have been able to with any other system.
Yeah, absolutely. It's yeah, I mean, it's at the risk of this sounding like advertorial or something. I'm thoroughly impressed. It works very well. Can we talk a little bit about like what's going into like how it's like all the data it's collecting? This is what it looks like, and I'll be showing pictures on screen here so you can see. But what it looks like is like a sensor that's on top of my fork, a sensor that's at the head of my shock. It kind of looks like, if you're familiar with the piggyback shock with like a reservoir, that's kind of where the communications and the little servos and stuff reside on the shock. But then it pairs it could pair to a whole other host of things that SRAM makes, because it's all wireless stuff that communicates on a Bluetooth protocol. So what data is Flight Attendant taking into account to make decisions?
Yeah, so maybe I'll again step like one layer back just to make sure everyone can kind of think about this and understand it. So we have Rockshox and SRAM work together. We're in the same company, and we use a shared battery across all of our Axis components. So the rear derailleurs, the seat posts that Rockshox makes, the Flight Attendant fork module, the Flight Attendant rear shock, all use the same battery that's interchangeable in between them. And then, as you mentioned, they all use Axis protocol, so they're all communicating to each other on the same Bluetooth network. If we just stick with Flight Attendant and like step up from the bare minimum systems that you would have, so you would have the fork module, which is, as you mentioned, mounted to the top of the fork. That is where the system does its thinking. And then you have the rear shock, which in this specific instance, we're talking about the Rockshox SID Lux shock with Flight Attendant. That shock is actually the same internally. It's exactly the same as our standard SID Lux shock. We've just put a motor and a Flight Attendant system on top of it and use that to actuate the damper inside the shock rather than a mechanical lockout, remote lockout, or one that's physically mounted to the shock. And then the next component that is a requirement for the system is a pedal sensor or a power meter. And that we need that to infer rider intent while you're riding your bike, and do some of the other systems like active ride dynamics, which is how we understand the amount of effort that a rider is putting into the system. And then beyond that, if you add more components to the system, like a rear derailleur, that helps us get a little bit more information. One
because the derailleur knows what gear you're in, I would assume, right?
So that's I'm glad you asked that question. One thing that I will say is going to be a little bit unsatisfying as a part of this conversation for your listeners is Joe and I will have to kind of pull back in a couple specific areas when you ask questions about specifically what is this component providing in terms of information to Flight Attendant to help it make a decision. This space is really, really competitive. There's quite a few different suspension competitors that are working on similar systems. And because the systems are evolving so rapidly and we are continuously updating what we're doing inside of our Flight Attendant system, we can't speak exactly to what information we're pulling from which component to create suspension states that we're going to give a rider as they're riding down a given piece of trail. So I know that is a little bit unsatisfying that we can't explain exactly what we're doing, but it's a really fast moving environment, and for that reason we can't talk to it.
Yeah, makes sense. I can state that, like, in the calibration process, when you calibrate it, it wants you on a level surface in a sagged position. In other words, like, sitting on the bike as you would if you were cruising along. And then it has you calibrate it by leaning it over to the side. So I would assume that it's taking into not only the motion that's going on with accelerometers, I assume, within this, but the motion that's going on with your bike in the front and rear, but also I would assume the lean angles, like in whether it's leaning to the side or whether we're talking, I guess it would be pitch, I don't know, but forward and aft perhaps too. But accelerometers are at play, providing information for it to make decisions. I would assume that's a pretty logical thing, right?
Yep, totally. Yeah, and that calibration process, and again, and this is actually a good thing since you've had this experience. you can kind of speak to it. One of the things we also wanted this to do is we want this to be as easy as possible for riders. Like you can imagine you could make something like this really complicated and really difficult for someone to get on a bike and just go ride. We do want this to be as like simple as possible. So if you had this on your bike and you were going to go for a ride, all you need to do is jump on your bike and ride. And inside of our app, you can see your battery levels, so you can make sure that you'll have enough battery to get through a ride. They last a really long time. I mean, I'm looking at my bike right now. I haven't checked my battery levels in quite a few rides. We do really want to keep it simple. And that calibration step that you did, you only have to do when you get the bike for the first time. And it is helping the system to know where the fork and the shock are relative to each other so that we can understand what the bike is experiencing while it's out on the trail.
That makes sense. And I think it took 30 seconds to do. And it's very similar to like a calibration offset that you would do with your power meter, but the cool part is it's way less frequent, right?
Yep.
You don't have to do it every ride like you do with a power meter. So a very common assumption, and again, you guys might not be able to speak to this, but a very common assumption that people have when, in fact, somebody sent in a question about this, they were like, does it just use a dropper post to know when I'm dropped? And then that way it locks out? That seems like a really simplistic way of going about it. Maybe you guys can speak to like, I guess, what things you feel like are most important to making decisions. I don't know if you can, but what things are most important to making decisions on how to adjust valving for the rider?
Yeah. So, I think a couple of things as we step into that, the first thing I would say is Flight Attendant doesn't set your bike up for you. So before you even start riding your Flight Attendant bike or had a Flight Attendant experience, you would want to do the same suspension setup that you would do on any other bike, where you're making sure the spring and your fork and your shock are set up properly for your body weight. Make sure the rebound is matched to that spring so that you're going to have the rebound feel that fits your preference, and then dialing in your compression based on whether or not your fork and shock have low speed compression adjust from there. So that would be like a, first jumping off point. And then actually, Joe, maybe I'll just like kick that question to you and you take it. Sorry, that was awkward.
Cool. For sure. So, again, playing things a little close to the vest, just because we don't want to spill all of our secret sauce out into the world. But, the things that we've found really important are listening to the rider and listening to the trail, which seems pretty obvious. But really, that's one of the things I think our system does exceptionally well at, is really understanding what the rider's intent is and like, what is the rider trying to get out of the bike? And that is something that, we did pretty well with our original version, with the trail and enduro version of it. But I think we really took it to the next level with this new firmware update, especially with the addition of adaptive ride dynamics. And so basically what adaptive ride dynamics does is it's listening to the rider on a whole new level. And we're really understanding, like, is the rider wanting an efficient suspension feel right now, or are they wanting a more comfortable suspension feel right now? And so that's really what it's all about. It's like trying to, honestly, it sounds kind of silly, but get inside the rider's mind and understand if they're pushing super hard, they probably want a firmer ride. If they're not pushing super hard, they probably want a more relaxed ride, and a more comfort-oriented ride. And so that's really what we brought into this new update. And it's really stacked on top of our base algorithm quite well, to where the basic algorithm was listening to the train really, really well. And then this just takes it to the next level of we're listening to the rider even better. So that's at a very high level. That's kind of what we're looking for. And we're always looking for ways to listen to the rider better. We're always looking for ways to listen to the terrain better. But, without going into any more details than that's what we're doing.
And that'll be a familiar concept for people listening to this. It's effectively breaks down your effort into zones. So very similar to like power zones and what people can think of there. And it uses that. And from what I understand, it learns like your power distribution over the previous 7 rides, I believe it is. That may be incorrect. And what it's doing is it's trying to keep track of like you said, that what the rider wants in terms of like if they're riding hard more frequently or less frequently, and it can kind of use that information to adjust it. Is this and this is something that you can change manually as
Correct.
Well, right? To be able to like go in and you can adjust those things, but it learns it for you. And on the learning side of things, TrainerRoad, we're doing things on the AI side of things and machine learning and using different learning models in various different capacities. You mentioned the word algorithm there, which typically operates either in conjunction or separate from learning models and that sort of thing. Is this using AI of any kind? And clearly there's opportunities for it everywhere. And I'm sure that you guys are excited by it if you're not using it, but are you using this at all?
I wouldn't call what we're doing AI yet. It's a buzzword that people throw around a lot with this stuff. And like at the basic level, like, could you describe this as AI? In some ways, maybe yes. But again, we don't want to divulge a whole lot, but we are looking at the last 8 rides. We are trying to figure out what your typical effort levels are when you're riding. And the one point I want to make with all of that is people get kind of hung up on like, oh, well, my FTP is this. What should my effort zones be? And it's like, it's more of like, what are you doing on the bike and how are you exciting the suspension of the bike by how you're pedaling and how much effort you're outputting? And so that's what we look for. It's less of a like what is your FTP? What can you do? Like what's your peak power? All that kind of stuff. It's more of like are you trying hard right now? That means you're probably exciting the bike more, which means we need to make a firmer ride for you. Are you not trying as hard? That means we need to do softer. So it's all on the lens of like, how is it making your bike feel, and less of like, oh, I'm crushing my last, FTP max effort or whatever. So that's one thing I kind of want to, because that hung up some of our test riders who are really into training with power. They're like, oh, well, it said I was here, but really I felt like I was kind of here. Maybe it's like, okay, but how did it make the suspension feel? And they're like, oh, it actually was doing exactly what I wanted it to be. I'm like, okay, cool. That's what we're going for.
Yeah. Yeah. So it's not power zones directly. It's just similar in the sense that it's classifying your effort in terms of power and using that information, right? Another thing I want to talk about here is bias adjustment. So the system has the ability to shift the bias, and I would so love to see a heat map, by the way, of this data, because like I have this assumption that over in Europe they're going to turn their bias adjustment way up. It seems that like European brands and European riders and everybody else, they prefer a bike that is stiffer, generally speaking, than what we tend to have over here in the Americas. Is that the bias adjustment? What's the intent there? Because this is an automatic system, right? So like, why are you adding in the layers of bias adjustment to it?
Jonathan, the one thing to look up is we actually do have a simulated trail scenario where you can see, and I'll make sure you get this photo and can include it, where you can see where the bias adjustment will change based on the trail inputs. So going back to Joe's points of we're trying to infer rider intent with our active ride dynamic system, the bias system is really like how you can tune the bike's response to the trail inputs. So it's really what's coming into the bike from the trail and how the bike is going to respond to that. So the bias system is really where you're able to best fit the bike's response to the trails around you. And we try to make it as easy as possible so that if you do go to a different riding area that feels like it needs a different bias setting, it's like one quick tap on the fork module and you can move it around. Or, I personally find that I kind of run 0 or +1, and that's pretty much the space that I leave it in no matter where I'm riding. So I'll make sure you get that trail layout, because it's kind of nice because you can see if we fix the rider output and we fix the trail itself in terms of its intensity, when you move your bias up and down, you'll see that in +2, you're going to be in a much more efficient state more often. And then in -2, you're going to be in a much less efficient state, a much more open, comfortable situation. And then, 0, which would be your middle point, you're kind of running right in between those two. What's nice about that graph too is that's another place where you'll be able to see the split state that I mentioned earlier, where the fork and the shock are doing different things to try to provide comfort while still giving you as much efficiency as possible. So the fork being a little more open than whatever position the shock is in.
That makes sense. Joe, I don't know if you have anything to add to that. I don't want to cut you off if you do. I have, of course, many more questions, but
yeah. No, I think Chris explained it fairly well. One of the things we were doing when we were designing the original 5 bias settings was really trying to get inside the heads, again, like I keep saying, of all of our different test riders. And so, it spans from like -2, which is a more comfort-oriented setting, to +2, which is a very racy, like aggressive, kind of really firm feeling setting. And our goal is to make each one of those usable in different scenarios and usable for different people. And so some people like a really more comfort-oriented bike, just how they ride, and so they're going to like a -1 or a -2. Some people want a really firm feel, so they're going to want a +1 or a +2. And then some people are kind of smack dab in the middle. And so we tried to really cover all of our bases and make everybody as happy as possible with each of the 5 bias settings. And so that's why there's 5. That's why those exist. It's because everybody wants something kind of different out of their bike. And that's one of the cool things about Flight Attendant is it is so customizable to what your own personal preferences are.
Yeah, and this is really different than on a traditional mountain bike. You might have compression level adjustments, so you can change like the compression tune of your shock in the wide open mode typically. I'm thinking of like on Fox shocks, sometimes they have like a little thing that you pull out and you twist from 1, 2, or 3, and then you let it go and it snaps back into place. This is very different. In most cases, at least in all the bikes I've ridden with that, you never once change that. Like you just keep it in the most open setting because otherwise the shock doesn't feel like it works. And this is totally different. This is an entirely different concept and it changes the way the bike feels. I totally have preconceived notions going in. Number one, like you talked about split state earlier, Chris, I was like, well, I'm going to like manually override things by never allowing my fork to lock out. And instead, I just wanted my fork to go between pedal and open, and the rear, I'll allow it to lock out. But then when I just press a button on my remote, that's when it'll manually go into an override locked mode. And that's what I'll want because I'm an experienced rider and I know what I want. And I decided to ride it wide open. I don't think I'll run my bike that way at all. I love it wide open, or I love it, I should say, leaving it automatic and letting it do whatever it needs. And I don't think I'm going to have to intervene. And the second thing is I thought for sure I'm going to want stiffer bias. And no, I'm riding at 0 and super satisfied. Maybe if I was riding something like Sea Otter or something, I would go up to a +1 or maybe, I don't know, +2. It'd be interesting to try it. But yeah, I don't think that I would change it. Maybe Moab in some situations. Actually, I'd probably want 0 in that situation too. It's just really good. Okay, I have some questions. With the brain, over the years, riding the brain, they kept shifting the location of the brain damper on the shock, trying to get it closer and closer to the axle. Now, the brain was like a mechanical version of something trying to accomplish the same goal of Flight Attendant in the sense that it was trying to know when to lock and unlock your bike. It was binary. It had locked or wide open. And it worked with like a mechanical thing that was basically trying to sense when it was being disturbed from just being in a smooth, steady state. And then it would open up the valving of the shock and then it would be plush. Otherwise, its natural state was locked. They kept moving that mechanism that was trying to sense motion further toward the rear axle. And there's this narrative that exists that if you're not measuring at the rear axle, then you're missing out. Like you need to be closest to that because that's going to move first or move most severely compared to something that is higher up the suspension chain, like on top of the fork, for example, or at the shock body itself. First of all, is that truly something that makes a difference? And then number 2, is that something like, why didn't you guys measure at the axles instead?
So that was first thing with that is the brain obviously is a very different system than what we're doing. And so there's an inertia valve in there. And so basically you have to get a bump that's big enough to make that inertia valve open up. So that's why getting near the rear axle is very important for that system. We're using electronics to sense bumps, it's an entirely different ballgame essentially. And, we are placed closer to the rider, and in a lot of ways, it's actually more accurate to what the rider is actually feeling because your suspension is absorbing bumps. And so we're getting a better kind of transmissibility reading by having it up there. I think you can make it work either way, but that's where we put it and it's working great. And, we haven't had any, there have been no negative effects of having it up there. And I'd say there are actually some benefits of having it up there. You are sensing what the rider is feeling a lot more than having it elsewhere.
Yeah, that makes sense. One thing that I noticed when I first rode Flight Attendant, I had parking lot tested it. And naturally, I did what anybody will do with a bike like this. And I went straight at a curb, right? And that was like the first thing that I wanted to test. And I noticed 2 things. First, it was locked when I was in the parking lot. And when it hit that curb, it felt harsher than it would have been if it was wide open. That was one thing. The second thing, instantly, the rear shock opened up and the rear shock just completely absorbed the impact that I had there. Now, when you're out on the trail, I never once encountered a situation where I felt like this was a problem, first of all. But I think it's an interesting observation that if you're just doing something that I don't think you guys probably didn't design for the use case of riding in a smooth parking lot and hitting a curb. And in this case, it won't perform in that regard like you would assume that this like automated suspension adjustment thing will with the fork. However, the really cool thing is that since the fork and the shock talk to each other, it's instantly that rear end locks out. And that's something that with, if I was riding something like the Brain or something else, I would have hit that with the fork and it would have been firm. I would have hit it with the back and it would have been firm. Whereas in this case, at the very least, the back is soft. Can you guys talk a little bit to that use case? Because I bet a lot of people are going to, quote, experience Flight Attendant in that context in which it probably wasn't designed.
Yeah, it's funny, and hopefully this makes you feel a little bit better about it, but the first thing that we did back in 2015 when we first started testing Flight Attendant was straight to the parking lot, straight into the curb. So we've done the exact same thing. I think this goes back to all the different pieces of information we're pulling in and our desire to understand rider intent in the given situation and then get the suspension to that desired outcome based on to the optimal situation based on rider intent. And so, if you are cranking on the pedals on a flat surface straight into a curb, which is not something you would do out on a trail experience, the system is going to do what it's going to do in that scenario. But, if you're out on a trail and you're pedaling along as hard as you can, the system is going to be able to understand a lot of different things about, like, is the trail going up? Is the trail going down? Is the trail bumpy? Is the trail not bumpy? And it'll use all that information to make the best possible decision for you. And I think, like, you have noticed in the riding that you've done on it, and so have our professional athletes, that it's not going to put you in a scenario where you're going to lose control or traction on trail because it knows and understands the trail scenarios really, really well.
That's a really good point. In reality, too, when you see an object like that, what we all do is we lift, or we unweight at the very least, but we likely lift our front end, right? And what I've noticed is as soon as I start adding in those levels of inputs, in other words, perhaps in your language, communicating my intent to the system, it starts making changes to the suspension. You can hear it actually, which is, I think is really cool. When you hear your bike making little changes, like you hear the servo motors going, but you can feel it. So like when you see that rock coming up and you pick up and lift up the front end, it's making changes to your suspension because it knows that you are lifting up and over something. So in practicality, I think it's solid, and you just can't apply the curb test, to things across the board. A couple other, can I ask some like future leading questions in terms of like, and a lot of this is probably going to be, pie in the sky sort of stuff, but I kind of want to ask you guys some questions because I think you're in the trenches with this, and a lot of us listening to this are from the road side, the gravel side, that sort of thing too. So hopefully it can provide some insight. And maybe even before I get into that, we've had these 3 damping settings on suspension, and I feel like it's a product of what we had in terms of how we interacted with our suspension. Because at first it was just 2 settings, right? It was open or locked. And then we got to this point where we had like a pedal mode. But all of that said, we kept it to 3 positions because if you probably went to like 4 positions or anything else, it would just get extremely confusing. Operating a lockout with the 3 positions, like you guys said before, I like to think that I'm a really good rider, technically speaking, have good technique that's well patterned in so that I can do things subconsciously. However, one of the biggest things that I notice with Flight Attendant is how free I am to handle my bike better because I'm not thinking about making those changes. If I had 4, 5, 6, or 7 options, I would be completely overwhelmed and I wouldn't be able to make those choices. So right now, Flight Attendant is effectively listening and then adjusting between 3 positions. Is 3 positions ideal? Or do you think that this is going to change suspension design? And are we going to have a much broader and maybe higher resolution spectrum between open and locked?
So I think that is a really great forward-looking question. I would say at this point, we're always working on new technology and we're always trying to improve how things are working. The level of complexity that's currently in the system balancing what's happening on what we would call the wet side, the damping side, and what's happening on the electronic side is really high. And we're really happy with how it's performing on the bikes today, like you've experienced. You know, so I don't have an answer to that question other than like we are very happy with how it's working with 3 positions at this point. I will though give like a quick explainer on how we're doing that specifically in the fork and the shock on the wet side, because one thing that you have to keep in mind is as your shock's moving, so you're pushing oil from one side of the valve to the other side of the valve, and if your system for closing that valve or opening that valve is impacted by the oil flow, it's going to take a lot of energy to close or open that valve. So basically, like if the oil is pushing against the thing that's trying to close or open that valve, you're going to waste a lot of energy, or maybe not even be able to do it as quickly as you want it to. So the valves that we design inside of this system are actually set up in such a way that they're neutral. They're not affected by that oil flow as they're making a state change. And designing that inside of like a shock that's teeny tiny is really hard and takes like quite a lot of engineering work. It both on the fork and the shock, they use a very similar design, although they're inverted from each other. But it's basically like a top hat design where the oil is able to flow out from a central post, and then a top hat goes down and closes off different valves. And because that top hat is translating over those holes, the oil flow doesn't resist the top hat's movement. But it did take us like quite a while to develop that system and develop it in a way that allowed it to be tunable and fit into the packaging constraints that we have both on the fork and on the shock side of things.
That's interesting. I hadn't thought about that before, about the resistance to change, right? Because of the pressure being applied to the system. And that's the other thing, is that could very well be happening under significant load, right? A rider landing off of a drop or going through bumps or anything else. That's all significant stuff.
Yeah, totally. And one like another layer I'll add to that is, one of the other things that we want to do is we want to have commonality between our cable actuated systems and our flight attendant systems, just because that allows us to, develop economies of scales with the development, and that makes it less expensive for everyone. The other thing that we want to make sure is, like, if you have a cable system, you can have a cable system fail and the lockout, the cable can break, or the ferrule can be not tightened enough. And if the system loses cable tension, we want to make sure that it's going to go to open and not going to go to lock, because if it went to lock, if it defaulted to lock in that scenario, then you would have a rider who didn't have traction and didn't have control, and that's just a bad scenario. So with all those systems, we design them all with the mind of they will default to open if there's a cable system failure. And so that's just another layer of complexity that we have to do on top of everything else that we're trying to do. But it is something that we think is really important.
Yeah, and Flight Attendant works that way too. If
Exactly.
you were to run out of battery or something, it would default to open. Whereas before, and I've had bikes set up with a lockout before where it didn't do that. I remember I had like a Monarch rear shock with RS1 up front. And I had the old hydraulic plunger lockout on there. And there were quite a few times where it was either the lockout or something else. It would fail, and then I'd have a very fully rigid bike. So yeah, I'm grateful for the effort, like you said, that you guys go to avoid that one. How is this going to affect bike design? Because there are brands like Yeti, for example, for a really long time prided themselves on building a bike that pedals extremely well, wide open, and also descends extremely well, wide open. In other words, they were kind of designing around this real world scenario where most riders probably wanted a bike that could do both. And then there's bikes like the Scott, for example, that Nino rides. And that one is designed in a very polarizing manner. The suspension is designed to be extremely plush, wide open, and not pedal well. But it's because they have this in mind that we're going to have 3 settings to take care of this. So we don't have to make it pedal well when it's wide open. With Flight Attendant making that even easier to be able to make those decisions and also taking care of all those decisions. Do you guys anticipate that this is going to be sort of like a chain reaction sort of a catalyst here that could change bike design?
We work really closely with all of our OEM customers, and I think that at the end of the day, they're the ones who are going to design their frames the way that they want to. But you can, the Scott example is a really good one, where Scott has a specific shock that they use with both a damping and an air spring change between their different modes, and that has freed them up to really, like you mentioned, like have a very open setting, move to a pedal mode that's like more trail, kind of pedal around, and then a full lock situation. But you can imagine that if a frame designer was going to work fully inside of Flight Attendant, they could do quite a few different things with their suspension design to be able to optimize for it. At the end of the day, it's up to the OEMs to decide to do that and to optimize in that space. But I definitely think it's something that it's an opportunity that's open, and it's a conversation that we have with them.
Yeah, and one thing I would actually add to that, setting aside any like major like frame changes, kind of like as Chris was alluding to, at the very least, what we've seen is it actually changes how our test riders set up their bikes. So we had one rider in particular who we usually run like 22% sag, so like running a lot of air pressure, and then using a really firm compression tune and all that kind of stuff. So his bike was pedaling efficiently whenever he was in open still. And so basically a really firm setup that was compromised for the descents, but it worked better kind of for the pedaling stages of a ride. He was trying to run that same setup on Flight Attendant, and we kind of started talking to him. We did some time testing with him. We're like, hey, you ought to try running a lot more open of a setup. And so we ended up lowering his air pressure, so it softened everything up. And we actually retuned his shock to have a more open compression tune on it. And so basically just a softer setup overall, and then rely on Flight Attendant to give you that pedaling efficiency when you want. And he actually got quite a bit faster times by just setting his bike up differently. And that was all enabled by having Flight Attendant on his bike. So, barring any major suspension changes or suspension layout changes from other major companies, at the very least, it allows riders to compromise less with their setup overall.
Yeah, it's funny you bring it. I'm glad I'm not alone, because I've typically ran somewhere around 20% sag. And I like a firmer underfoot feel a lot of the time with my bike too. I put in a lot of energy like into the bike, and I like the bike to not just soak all that up, right? And that's what I've typically ran. And I rode the Epic 8 without Flight Attendant for the last 2 months, and then I put on Flight Attendant. And at first, when I set up the Epic 8, I was not satisfied with it because I was running at 20% sag. And then after talking to them, they're like, hey, we really designed it for this pedal position to be specific and to operate with more sag. And they designed it really with this intent that they would have Flight Attendant or a person using a 3-position lockout to change it. I'm at 30%. And the bike is awesome. It eats, it's going to gobble up anything in front of it. And then at the same time, you never have to worry about the compromise. So yeah, it's already seeming like it's changing suspension design in terms of how people are tuning things. And I'm sure it'll change from there. Maybe Joe, you can speak to this on the tire and wheel design, like what a person is trying to do when they're trying to set up their bike and to get the ideal setup is to get kind of like a total system compliance and to find whatever that ideal compliance is for them. And tires and wheels play a huge role in this. We've seen a shift over recent years toward people running less pressure in their tires and running inserts to change the feel, not just for protecting the rim, but to change the feel. I've been one of those riders that's been running a lot lower pressure and running inserts and having kind of like a initially plush feel out of my tires with a faster ramp up, right? Like a more progressive air spring by doing that. However, I'm not doing that right now because of the fact that my suspension is taking care of so much of the change there. So I guess on the tire and wheel side, have you guys noticed any changes with athletes running tire pressure differently?
I haven't seen that personally yet as much. Most of the changes I've seen have been on the suspension side, but that's also, what I do day in and day out. So that's really what I'm focused on. Maybe Chris can speak to that as far as tire and wheel setup changes more, but yeah, I haven't seen any of that yet.
Yeah, I can't. I'm not aware of any tire and wheel changes. I haven't heard about that. I will use this opportunity to do a shameless suspension plug thing here on one of my pet projects. It's like trail and enduro and downhill bikes where people Or like, oh, I have a lot of travel. I need to like spend some time doing some bracketing on a short lap to like make sure my suspension is optimized in terms of like the spring setup and the rebound setup. Um, Cross country riders have less travel, and so they need to be like way more specific and ensuring that their suspension
Well,
is
thank you.
working perfectly for them.
Thank
Um,
you for saying that. I feel so identified because it's typically the opposite. Like I feel like people say that, like the DH guys and everything else and the enduro guys, they're the ones that get high and low speed compression and rebound. They're the ones that get all the adjustments. But ironically, I find that typically speaking, a more general population rides those bikes and they might set their sag.
yeah,
But other than that, they don't do anything. Meanwhile, like the cross country guy is like, I mean, he's literally weighing the grains of rice that he eats,
yeah,
right? Because he
but
wants to make sure that everything is optimized. So this is great. Thank you. This is the cathartic for me.
yeah, yeah. So and I mean, I will tell you, like I use this almost the same setup procedure for my cross country bike as I do for like a trail or enduro bike, where when I got my new Epic 8, I took it out. I took it to a short section of trail, actually that Joe's ridden here in Bellingham. I started on our like baseline settings. I did that I found via our Trailhead app. Where I typed in the product that I had, my body weight, and then it gave me an air pressure setting and a rebound setting for the fork. And then I used SAG to set that on the rear shock. And then I did a lap on that short run. And then I increased my air pressure a little bit on my fork based on some of the things that had happened on the trail, and went and did another run and then changed my rebound setting. The point being, I went and I took the time to ride a short section of trail that was representative of the kind of riding I was going to do. I asked myself what that short section of trail felt like, what I wanted to improve or needed to improve. I looked at the O-rings on my fork and my shock, so I would reset the O-rings on the fork and my shock every one of those runs. And I spent the first like 30 or 40 minutes of the ride just repeating a relatively short section of trail, and making changes one at a time to my suspension to get it to a place where it was working optimally. I also think the practice of doing that is really helpful for riders because it allows you to feel the different changes you're making. So, you as a rider, you might not feel like you know what your suspension is doing or how to change your suspension. But if you take the time to go out and ride a section of trail and then go up and change your rebound clicks by 4 clicks and then ride that section of trail again, that will allow you to feel what rebound does for you and how beneficial or detrimental it can be if you have the right setting or the wrong setting on rebound. So I would say like that is really important for cross country. It kind of gets really touted in the enduro and downhill space, but it is super important for cross country.
Yeah, that's great advice on how to bracket and tune. That was awesome. Thank you, Chris. I think the last question I have is, it's kind of like two parts to it, but you have the Rockshox Rudy fork. I've seen World Cup racers actually running the SID on like a hardtail bike or something like the Epic World Cup for, those sort of things where they're just running Flight Attendant on the fork, it looks like. So it seems like it would certainly be possible. Are you guys looking into this, or is there curiosity for gravel? Again, this is a competitive and fastly developing space, so you probably can't reveal too much, but there seems like there's got to be opportunity for it.
Yeah, I would say thank you for noticing all of that. And I would say the Rudy is another really good example of a product where, what we're looking to do is provide traction and control for riders. And I think there's a lot of gravel riders who probably will be able to go a lot faster if they put that on their bike because they would have so much more control on the rough descents or just even the rough flat sections of trail. And it also greatly reduced their fatigue. In terms of like future developments, we can't really speak to them, but we are like looking at all the different places that we could apply Flight Attendant and suspension to gravel in general. I mean, I think the gravel specific seat post that Rockshox makes that has the ability to run full firm at top out, and then if you move it just a little bit into the travel, it allows it to have a little bit of the seat post gets a little bit of squish. again, that's just like optimizing for traction and control. Like you can scoot your seat down just a little bit, still have good leg extension, but be able to pedal through rough terrain without getting your butt knocked off your seat. Again, just traction and control.
Yeah, there's got to be opportunity for that. I'm eager to see where that develops. You guys don't have to say anything, but I feel like it's going to happen. So I have zero insight. I just looking at it, everything that all of us are looking at. Road bike side of things. Can we talk about that? Because F1 cars, they don't go on anything rough, but they have suspension. And I feel like road bikes for a really long time, like we get our compliance out of our tires, which are an uncontrolled system, right? In the sense that you can't control the rebound damping, for example, for that. Instead, it's just going to rebound as it does. And traction's a huge, or I guess a very apparent limiter in road racing that causes issues. Very commonly, it's due to bumps that are encountered, not just lean angles that are excessive. We've had bikes like the more endurance-oriented bikes, like the Specialized Roubaix is a really common example that we think of that try to introduce compliance into the frame. But again, it's not necessarily, it's a very like simple suspension system, and that it's just going to allow some vertical, like up and down is going to take some harshness out of some hits. But that still, it springs back into position. Why don't we have systems like this on the road? Or I guess, is that the future? Where we're looking at. If it works for F1, why not on bicycles?
Yeah, I can't speak too much again to like what the future holds, and everything you said makes total sense. I think there's always like the weight consideration as you go into that. I personally used to have a BMC ERS, which is a gravel bike that has rear suspension, and then I ran a Rudy on the front of it. That bike was amazing. Not only amazing like in rough stuff, but it also had a really incredible cornering feel, even on like road turns, because like it felt like a ski that had a good amount of camber and side cut. Like it wanted to work its way around the corner, whereas I feel like road bikes sometimes you're like leaning them to get to go around the corner, just like a relatively straight ski would feel. Like you really have to put it on edge instead of like pushing it in and getting a nice turn out of it. So yeah, I think all your points are good as to the road side of things, but and it's something that we're watching and paying attention to, but unfortunately nothing to say today.
Yeah, understandable. This is so 1.8% faster is what you guys looked at in tests. Independents have looked and seen 2%. Your mileage may vary, I think is a good thing to apply to that one. And it seems like a conservative estimate is what we got. But 1.8% is not nothing. I'm thinking of, now granted, you can't compare 1.8% in terms of time across the board. And I'm not sure, when you guys are measuring that 1.8%, was it in terms of time? Or how were you guys, the speed? Okay. Yeah. So, I mean, if you're looking at things in terms of speed, 1.8% faster in speed, races have been decided by much less than that. So it's cool to see innovation pushing in that regard where we're actually getting that sort of improvement from things, but certainly isn't cheap innovation, like, I don't know, like drinking tart cherry juice or something like that. But also it seems like perhaps it's a bit more concretely effective. I really appreciate you guys doing this and putting up with my probing questions and asking toward the future and all that stuff. If you're listening to this right now, listeners, and you appreciated this more technical talk, let us know. And if you have any questions for Rockshox, let us know as well, and we can get them to Chris, Joe, or anybody else at the team there. Yeah, I really appreciate it, guys. Is there anything else you wanted to cover before we sign off?
Well, from my side, I mean, I just, again, make sure you take the time. You bought an expensive bike, get out there, do a little bit of bracketing, focus on the setup of your bike. That would be I would think the thing that is going to help your ride experience the most is taking the time to do that.
Nice. And Joe, anything else?
I just really appreciate the time, appreciate all the questions and the opportunity to get to talk about this.
Yeah, cool. Thank you guys for building cool stuff. I'm excited to see what the future holds, and I'm all for all sort of this using technology to help us go faster. Don't turn my pedals for me if I'm in a race, I guess, but short of that, let's keep it going, right? And that'll help. So, and even then, let's turn our pedals. Let's do e-bike races. I appreciate you guys so much and everything that you've done. We'll talk to you all soon. Thanks everybody.
Thank you.